Welcome to the Deep Dive. Today we're tackling something straight out of sci-fi, faster than light travel.
Yeah, but not like you usually see it in movies with flashy warp drives. We're talking about the Auberine spacecraft's magnetoinertial drive, or MIDI. It's quite different.
More elegant, actually. Definitely a bit mind-bending, too. So today we're going to pull back the curtain and figure out how this thing actually works.
Right, and the cool part is, it doesn't rely on raw power pushing against space. Instead, it creates this controlled gradient, like a slope, in spacetime itself.
Exactly. The ship's not fighting its way through space. It's more like it's sliding downhill at faster than light speeds.
That's the key. It sidesteps the huge issues from general relativity, like the energy problem when reaching light speed and the massive time dilation.
All right, so let's dive into the mechanics. I'm guessing the engine requires a ton of energy.
Oh, absolutely. It pulls power from the ship's 1.2 gigawatt Mercury MHD fusion reactor, a dedicated power source.
A gigawatt reactor. Wow. So how does the actual mechanism work? How does it create this wave?
Well, it uses nested concentric rings made of ultra-dense exotic matter. These rings are magnetically levitated and spun at near light speeds.
Exotic matter, huh? What does that mean exactly?
It's theoretical stuff with properties that allow it to create huge gravitational effects in small spaces. It's crucial for this system. And these rings are spun in opposite directions near relativistic speeds.
Spinning rings of exotic matter. Then what?
Then the AI Athlon steps in. It modulates the resonant frequencies of the spinning rings, kind of like tuning forks. But instead of sound, it's creating interference patterns, constructive and destructive, to sculpt space-time itself.
That's wild. So the AI essentially shapes the space-time gradient ahead of the ship, giving it that downhill slope.
Exactly. And all of this, even with the gigawatt reactor, would be impossible without the gravicompensators.
Gravicompensators? What do?
They're efficiency multipliers. They reduce the ship's effective inertial mass, making it feel much lighter to space-time.
So the ship feels lighter, and that cuts down on the energy needed to create the space-time slope?
Exactly. It solves the massive energy issue that usually plagues FTL tech. It's a complete game changer.
And I hear they do more than just that?
Oh yeah. They handle active stabilization, precision maneuvering at sublight speeds, and even maintain a stable 1G environment inside the ship.
No crazy G-forces or time distortions for the crew?
None at all. Since the ship isn't being pushed through space, it's more like it's carried along with its local patch of spacetime.
Like riding a magic carpet, right?
Exactly. You feel perfectly stationary even though you're moving at FTL speeds. Time inside the ship moves normally too, so no time dilation issues.
That's incredible. But managing all of this must be insane. The rings, the frequencies, the power. Must be a lot for a human to handle.
Absolutely. That's why the Athlon AI is so vital. It's not just calculating, it's orchestrating trillions of calculations per second, constantly adjusting the system in real time.
So it's basically the ship's brain, making sure everything runs smoothly.
Yeah, it's like the ship's intuition. It fine-tunes everything, making sure the space-time gradient is perfect, handling the power flow, and even translating navigation commands into subtle shifts in the gradient.
So, if we boil it down, what's the big takeaway about the Auberine drive? What makes it revolutionary?
I think the key is that it's a unified system. It doesn't rely on propellant. Instead of moving through space, it moves space-time itself. That's the fundamental shift.
Moving space-time itself. That's huge. So, what stands out to you about a technology that can manipulate the very fabric of reality? How might that change our whole definition of travel?
That's a great question. I think it really redefines what's possible. Not just in terms of speed, but also in how we interact with the universe. It could change everything, from how we think about distance to how we explore the stars.